morning. So hello and welcome back. We are now in lecture 10, the second lecture of the 15th week of Math 211. Oh my God, we are a third of the way through the semester. Can you guys believe it?
Nope.
Time flies when you're having so much fun. And I'm going to share my screen here. Okay, and we're gonna go, we did fair price. We did this group activity.
We're on page 12.
We're on page 12. We did this one, I believe. We did this one, I believe. We're up to this one. We didn't finish this. I know we started it, but I don't think we finished it, correct? Did we? Anyone remember? Did we finish this? No, I don't think we did. Okay, so an American roulette wheel has 38 pockets, 18 black, 18 red, and 2 green. You bet $1 on red and the wheel is spun. Now the actual payout if you win is $2. Your original dollar back plus $1, right? If you just got your dollar back, it's like, what's the point? So how much do you expect to win each time you play? So the first thing we want to do is we want to make a table of every amount that you might win under every possible scenario with its corresponding probability. So if I put $1 on and I don't get the dollar back, if I don't get red, how much have I won for that one? If you bet $1 and
-1.
-1, I lose $1. And if I bet $1 and I win, then I win $1. I get my dollar back, but I'm only really profit $1. So either I'm going to go down $1 or I'm going to go up $1. There's not really any other options. Do we agree with that? Hold on. Someone's working on trying to get it connected. Question, but are you on mute? All right, is that rude to ask that? If someone says I can't hear you and I'm not sure why, and I say, are you on mute? Is that like really a bad thing to ask?
No.
All right, seems like, my computer's not working. Well, did you turn it on? It's kind of like a, it can be very, condescending. Anyway, okay, so now the question is, what is the probability that I lose $1 or that I win $1? We need each of these probabilities. What's the probability that I win $1 or I lose $1? Anyone? What is the probability that I win or lose $1?
Well, for black, it's 18/38, right?
Well, I'm not betting on black. I'm betting on red, right?
But if you're losing,
So if I lose $1, that means it didn't land red, correct?
correct.
So what did it land if it didn't land red?
Black or green?
Black or green.
Oh, okay.
And how many ways are there of getting black or green?
20.
20.
20. So the likelihood of losing $1 is 20 over what?
38.
20 out of 38. And what's the probability of winning $1?
18 out of 38.
18 out of 38. Lovely, because there's 18 ways of winning $1 out of the 38 possibilities. Of course, the probabilities have to add to 1, of course, because it's got to be one or the other. So they have to add to 1. So the question now becomes, what is my expected value? How much do I expect to win on the average each time I play? How do I calculate expected value? We did this last time. Anyone recall? How do I get my expected value?
-1 times 20 divided by 38 plus 1 times 18 divided. Okay, and then the whole thing.
And what do you get?
So it's -2 over 38.
So I expect to lose 2 over 38 each time I play. Now, It's kind of hard to visualize 2/38, especially when you're talking about dollars. But if I convert that to a decimal, then I expect to lose a little more than 5 cents every time I play. So if I decide to spend the night playing roulette, I expect on the average to lose 5 cents each time I play, but hell, if I'm having fun and I spin it 1,000 times at a loss of approximately 5.26 cents per time, how much will I lose over the course of the entire night if all I do is bet $1 on red every single time I play? That only is going to cost me $52, right? 5 cents each time for 1,000 times on average. That's 53 cents. I'm sorry, $53. As long as I'm having fun, you might think it's worth it. Does that make sense?
Yeah.
Now, what is a fair amount to pay me if the ball lands on red? What's a fair amount to pay if the ball lands on red? Clearly, giving me $1 is not quite enough to make it fair. I'm still going to lose in the long run. If it was truly fair, would they need to pay me more than $1 or less than $1?
Less?
Well, if it's already not fair in their favor by them giving me $1, if they gave me less than $1, that would only increase the unevenness, correct?
Oh, more.
Yeah, they got to give me more than $1 to make it fair. Well, how much more than $1? How do I compute the value that would make it fair? This is a new problem. Instead of giving me the X's and computing the expected value, they're giving me the expected value and asking me to compute an X. How do I do this?
Can you just add the 5 cents to the dollar that they're already paying you, so it balances out, so that give you 1.0526? I guess the formula would be subtracting the estimated value if you're trying to make it a fair equation.
I see what you're saying, and it certainly seems logical. But I don't think it's correct, because I know the correct way of getting the answer, and I'm doing it in my head, and I'm not getting that. But it certainly seems logical. Just give me 5 cents more than you're already giving me. The problem with that is if you give me $1.05, that's what you would give me when I win, but you're still giving me nothing when I lose. So the 5 cents is not really making it into every roll.
Yeah, that makes sense.
In a sense. So what we're going to do instead is go back to the drawing board and say, I still know my probabilities. They're not changing. I still know that I'm going to have a 20/38 chance of losing $1 and an 18/38 chance of winning something. And now that something, that's my unknown. That's the guy I'm looking for. And from a mathematical standpoint, when you're looking for something and you don't know what it is, we learn in basic algebra, you give it a name. You call it something like George or Ralph or X, and then you try to come up with an equation that allows you to solve for it. In this case, what equation could I come up with that would allow me to solve for X?
-1 multiplied by 20/38 plus x over 18 over 38 equals 0.
Plus X, what do you say next? That came next? X what?
Multiplied by 18 over 38,
Gives you what?
0.
That is correct. Because this is just a formula for expected value. And this is when it makes it a fair game, if the expected value is 0. So my goal then is to solve for X. How do I solve this equation for X?
Get X by itself.
100%. So how do I do that?
Divide by X.
Well, if you divide by X,
Should, wait,
you're not getting X by, remember, to get X by itself, I have to remove all the other stuff that's around the X.
Oh, yeah.
so wouldn't you, first you multiply the -1 times the 20 over 38? And
By
then
what?
that'll be,
Yeah, that'll be
so
what?
like, then that'll be -20 over 38. And then you'll subtract that on both sides, which then becomes positive.
So what should I be writing? What should I be writing?
-20 over 38, because then it's already multiplied, plus X times 18 over 38. And then it'll be minus
Equals what?
0.
Okay, so that's, you're just repeating what I started with.
Well, sorta, because then you're sort of solving it, but then in order to move it.
Well, that's what I'm asking you. I mean, all you just told me right now is something that I already had that down here. So I haven't done anything yet.
Uh-huh.
So the question now is, what's the first thing that I should do in my effort to solve it?
You should divide 18 over 38 so you can multiply by the reciprocal on the other side.
That in theory can work, but it's a little complicated because I have two terms. What I want to do first, I want to add this to the other side.
I think that's what the other girl was saying. She was just step by step doing the multiplication and then adding to make sure it goes over.
Yeah.
Gotcha.
Yeah.
That I misunderstood. I apologize because I was just writing what you were telling me, and I didn't realize what you were going for. So my apologies.
Yeah, I learned math the same way. You've got to do it like step by step. So you do the multiplication first, and then you move, and then you divide. All of that stuff.
You could do the multiplication first, but I'd actually recommend not doing that way first. Because, I mean, here it's okay because they have the same denominator, but in general, I want you to imagine the guy that you're solving for, which is X. And what did you do to X to get the entire side? You first multiply by this, and then you added this. If I want to undo these, I got to go in reverse order. So I first should get rid of this, and then get rid of this as a general.
Yeah, that's what I was aiming for.
Okay, then I apologize, because what I was looking for was just X times 18 over 38 equals 20 over 38.
Yeah.
I was looking.
Yeah,
for,
it will
I
get
didn't
that,
hear,
yeah.
I didn't hear it, so I am sorry if that's what you meant. But I didn't hear that. So if that's what you were going for, my apologies. But this is what I'm looking for. If you add this to that side, we get this. Do we agree so far? And again, if that's what you were saying, Mom, I'm sorry. I didn't hear it. I didn't hear it. You all with me?
Yes.
Yeah.
Yep.
So now how do I get X by itself?
Multiply by the reciprocal.
Multiply by the reciprocal of what?
18 over 38.
So multiply both sides by 38 over 18.
Yep.
If I multiply both sides by 38 over 18, then the 38s cancel, the 18s cancel, and sure enough, I have x by itself. Here, the 38s cancel. And what am I left with? X equals what?
20 over 18.
20 over 18. And what is 20 over 18 as a decimal?
10 over 9. Let me get it. 1.1 with a bar.
So $1 and a little over 11 cents. $1 and a little over 11 cents would then be a fair amount for them to pay you. If they just give me 11, doesn't quite make it. So again, my apologies for not understanding where you were going, but does that make sense across the board?
Yes.
Okay. So now, let's do this one. One of your 5th grade students hears that the life expectancy at birth in the United States is 78.7 years. He has no idea what this means. Well, how would you explain it? How would you explain it? This is for everyone, by the way. It is open to the whole class. So don't think it's the guy next to you who I'm asking. I'm asking everyone. How would I explain? How would you explain to anyone when you hear the life expectancy in the US is 78.7 years? What does that mean? Does that mean when you're born, it's expected that you're going to live 78.7 years? Is that
No,
what-
it's the opposite.
Opposite? So negative 78.7 years?
That you live the average age of 78.7 years.
What does that mean? Explain again.
That you usually die at that age.
Okay, so that the age when you die, you are most likely to live to 78.7 and then die than any other age. I leave out. Is that what you're claiming the life expectancy is? Again, not saying you're wrong or right. I'm just asking you if that's what you're saying.
I don't know. I'm second guessing now.
Okay. Oh, it's the third guess that's the best. Anyways, would anyone else like to venture a?
Isn't it like based on statistics though? Like,
Of course it
like data, like how she said, it's like the average of like when the age of like when people tend to die.
Okay, but you said something that she didn't. She said it's the age that you are most likely to die. And you said something about it's the average age, which is very different. The first answer seemed to be about you in isolation. You're born. When are you going to die? You're going to die when you're 78.7. But the second answer was about an average. And life expectancy is about averages, not about you. If I measure or if I record the age of death for lots and lots and lots and lots of people, on the average, they will die at 78.7 years. It does not mean that you are most likely to die at 78.7 years. Do you see the difference between those? Yes, no, maybe so. Is anyone here?
Yeah.
Yeah.
Okay. Expected values is a long-term average. It's always an average. It's not about individuals. It's not about one data point. If you roll a die, one die, what outcome are you most likely to get if you roll one die? Which number from 1 to 6 is most likely?
They're equally likely.
They're equally likely. They're equally likely. But in the long run, if I give you a dollar amount equal to what you roll each time you roll, then in the long run, how much do you expect to get on average per roll? The answer to that is the expected value, which is 3.5. You can't get 3.5 on any roll. It's not one of the possible answers. But your long-term average is 3.5. Expected values, long-term averages. Questions on this? Questions on chapter 7? Yes, no, maybe so?
This is like a random question, but what does the 0.7 mean in 78.7?
That means, you don't die on your birthday. You die, 7 or 8 months in. So your next birthday,
Okay.
78 plus a bunch. Okay. You know what? I've done this chapter before, and I gotta be honest, it's not really as important as others. We're gonna skip it.
Professor, can I ask you a question about the last chapter?
Yeah, of course.
Can we just do like a super simplified example of how to find the expected value?
Sure. Why don't we look at the homework? Let's do number 2. It says about 70% of LAUSD students are Latino, 10% are African American, and 17% are something else. I don't know if this is accurate. Is this accurate? I never went through LAUSD. Would those of you who did this seem like it's a relatively accurate statistical data?
Yeah, pretty accurate, actually.
So Caucasians are really a big minority now. I guess when I say Caucasians, I don't mean Latinos, but I guess white non-Latinos is a minority. Is that correct?
Well, it depends on the area too.
Or actually, I didn't go to the UST, never mind.
I'm sorry?
For,
Yeah, I know
for mine, it's pretty accurate.
it is pretty accurate. No, I know that, of course, different districts are going to be different. This is compiling everyone. I just didn't realize this data was I went and guessed it. Let's just put it that way. So, okay, fine. 73% are Latino, 10% are African American, 17% something else. So the question is, what is the expected number of Latino samples in a random sample of, actually, you know what? This one is not what I'm going for. So okay, what happened here? Okay, here we go. I'm gonna do a different one. Okay, what's number 6? It says in a carnival game, the player rolls a die and is paid $1 for every spot that shows on the top face. It says construct a probability distribution table for this game and compute this expected value. So how would I go ahead and do that? What is my probability distribution table going to look like? What is my probability distribution table going to look like?
It's gonna one. It's gonna be numbered 1, 2, 3, 4, 5, and 6.
Those are the only 6 possibilities. Wow, that's those are the only 6 possibilities for rolling a die, correct?
Mhm.
And what is my second column going to look like?
1, 2, 3, 4, 5, and 6 as well.
No. Why would they be 1, 2, 3, 4, 5, and 6 as well?
Because if you get paid $1 for every spot that shows, if one were showing, it's saying like you roll the dice and then whatever number you get, right, on the top.
Yeah.
So then if you get 1, you get $1. And if you get two, you get $2 because you get $1 for every spot.
But wouldn't you get $4 basically?
$4 for what?
Like, well, oh.
Well, you
maybe-
don't spend money to roll the
Hold on.
die.
Oh, okay.
Yeah,
okay,
Wait, hold
my
on,
bad.
guys. The second column are probabilities.
Oh,
Oh, shoot. Yeah, sorry.
Second column is what are the likelihoods of getting all these amounts?
One out of
six
six.
Would that be 1 out of 6?
For all?
1 out of 6 for all of them. They're all 1 out of 6. They're all 1 out of 6. It's a fair die, presumably. Let's assume the carnival carny guys are not, scamming you.
Yeah, it's probably trick dice.
Right. So let's assume we'll assume it's 1 out of 6. We'll assume it's 1 out of 6. You can't trust those guys. So now, what is the expected value? How do I compute the expected value?
Would you have to add all of them?
Well, what's the formula for expected value?
Don't you multiply the left and the right and then add all those answers?
So let's go ahead and do that. Multiply each number on the left by each number on the right, the corresponding number, and then add them all together. When I do that, what do I get? What do I get when I add them all together? Anyone? Is anyone doing it, or are we all just waiting for someone else to do it? Because that would be really awkward and take forever.
I'm doing it, I'm doing
Yeah, I'm
it.
doing it.
Okay.
Is it 3.5?
3.5. So that means if you play the game once, one time, how much will you get? If you play the game once, how much will you get?
$1.
$1? You're pessimistic. Why $1?
Oh wait, when else? Well, if they win, they get $1.
Well, actually, if they win, well, they're always going to win because no matter what, you get money. Right? What's the game? How much you get in this game? What are the
You get
rules?
$1 for every spot.
$1 for every spot. So if you play the game once, how much do you expect to win?
Like $4, $3, $4.
Well, why $3 or $4? Why not 1, 2, 5, or 6?
Because the estimated value is 3.5.
First of all, it's the expected value.
Expected value.
Second, the expected value only tells you what happens in the long run.
Oh,
it's
so if you
impossible
play
to
like
tell
100 times, you'll
Nothing about
probably,
one roll, huh?
like if you play like a bunch of times, then you'll probably be at around $4.
Well, actually, let's say you play 100 times. Let's say you play 100 times. How much money would you have at the end of those 100 times? Approximately. This is for everyone. If you play 100 times, how much money do you expect to have in your hands? Minus whatever you pay to play. Just the amount they give you. How much do you expect?
350.
350, because on the average, you're gonna earn $3.50 per game played. I can't say anything about what happens on this game or the next game. But I can say in the long run, you expect to get approximately $3.50 per game. So what's a fair price to play? How much should I spend in order to be given this opportunity to make money?
$3.50.
$3.50. If every time I play, I spend $3.50, and then on the average, I get $3.50, then I'm gonna break even, and that's by definition what a fair game is. Does that make sense?
Yeah,
Okay,
thank you.
you're welcome. So at the end of the semester, I always run out of time. I don't do everything I want to do. And 8 is H is not as important as some of the other stuff. So we're gonna skip 8s. And there's no 9. And then there's 10. Which is now a whole different ball of wax than what we've done up until now. So I mentioned last time that I reserve the rights to add 7 to the first test. I'm going to do that because I think it all goes together. We're going to skip 8. So the first test is gonna cover 1 through 7. Okay, and the test, remember, is a week from today. You'll have it, you'll have the weekend to do it. Okay? Yes, no, maybe so?
Yeah.
Okay, and then 7, 8, we're skipping.
You
9.
said that the quiz is we're gonna have the weekend to do the quiz.
The quiz this weekend is gonna cover 5 and 6.
Okay.
Maybe some of 5, maybe 6, maybe both.
And then the midterm is next weekend, right?
Next weekend is gonna cover 1 through 7.
1 through 7 next weekend. Okay, good.
1 through 7 next weekend.
Cool.
But now we're gonna start chapter 10, which is displaying quantitative data. So first, you should be aware that data comes in 2 basic categories: quantitative and categorical. What's the difference between quantitative data and categorical data? What's the difference between quantitative data and categorical data?
One is numbers and one is words.
Okay, that's a great starting point, but it's not entirely percent accurate. Because there are sometimes numbers that are not actually considered quantitative. And we should really understand why. So if I'm curious what the average age of everyone in our class is, what can I do? How would I compute the average age of everyone in our class?
Add them up and divide by the number of students.
Add them up and divide by the number of students. And if I wanted the average heights, how would I do that?
Wouldn't it be the same?
Same thing. And what if I wanted income and SAT scores and GPAs?
Exactly the same.
They're all the same thing. Okay, you can add them up and you can divide by how many you have. And that value that you get at the end has some meaning to it, correct? The average height, the average age, the average income, and so on. Right? I can associate some meaning to that as a typical value, correct? Yes, no?
Yeah.
Okay. So now what I want to do is I want to do the same thing for everyone's zip codes. I would like everyone to write down their zip codes, and I'm going to add them all up and divide by how many we have. Does that result mean anything?
No.
But I did exactly the same thing as the rest. I added them up and divided by how many I have. Right? I did the same thing, correct?
Yep.
So the difference is that even though we use numbers to describe zip codes or phone numbers or potentially other situations, that doesn't by itself make it quantitative unless you can do math and the math makes sense. And what I mean by math, simply adding and averaging is really all that you need to determine whether it makes sense or not. So just because you see numbers doesn't automatically mean that it's quantitative. You should look at the context to make sure. But for the most part, numbers do mean that you're looking at quantitative data. Okay? So what are some categorical data? Things that are not numbers: gender, religion, language at home, country of birth. These are all things that are just categories, right? Male, female, or non-binary categories. Religion, Christian, Jewish, Muslim, atheist, Buddhist, Scientologists, and anyone have anything else? Did I get them all? Aren't there like umpteen religions in the world, and I can only think of 5 of them?
Hinduism, Zoroastrianism.
Zoro, what he said. What else?
Yep, that one.
Are there other ones?
For sure.
I can't think of any. Oh,
Did you say Buddhism?
yeah, I said Buddhism.
Uh,
I was gonna say Jehovah's Witnesses, but isn't that like a Christian thing?
Mormonism.
Mormon? No, but isn't that Christian too?
It is, but it's like
No.
there's a third testament. So
Oh, so there's like Lutherans and Catholics and
Anglicanism and
Yeah. There's like a-
Adventists, and then et cetera, et cetera, et cetera. There's like a big old branch.
we'll just say Jesus lovers and keep them all together. How's that? Right? Because I'm Jewish, so I don't know any of that stuff. That's just. But even in Judaism, we have different. I don't know if you would call them denominations necessarily, but we certainly have different philosophies in Judaism about how you go about practicing your religion, but they all fall under the umbrella of Judaism. And I don't know if Christianity works the same way. I don't know if all these different types would still fall under the umbrella of Christianity. Anyone here expound upon that? Because I just simply don't know. Would you say, would Mormons call themselves Christians? I learned about religions and math. Okay. I don't know. This is not my thing. So there's a lot of stuff in the world I don't know. And sometimes some of you can educate me more than I can educate you in various areas. So, it's a two-way street, or it should be a two-way street, right? You never know where information can come from. But anyways, you have quantitative data and then you have categorical data. Now, the methods of displaying data depends on whether it's categorical or whether it's quantitative. We do not use the same types of displays for both. For quantitative data, we use certain types of displays, and for categorical data, we use others. The basic ones for categorical data, I'm sure you've seen them, are pie charts and bar graphs. Have you guys seen these things, pie charts and bar graphs?
Yes.
Okay, none of them are here because it's not a chapter on categorical data, but pie charts and bar graphs, I can use 1,000 words to describe them, but if you just do a Google search for what's a pie chart, bam, oh, that's it, that's a pie chart. Oh, that makes sense, I get it. It's very straightforward. But this chapter is on quantitative data, and we have multiple methods of displaying quantitative data. Does anyone know what some of those methods are for displaying quantitative data? Anyone know?
Scatter plot?
Scatter plot is not, well, scatter plot would be for quantitative data, but a scatter plot is when you have two variables and you're seeing if there's a connection between them. And right now we're focusing on one variable at a time. So while scatter plot would work, it's not what I'm looking for here.
I don't know.
Isn't
What about the
it
dot ones?
There's a dot
a
plot.
line graph?
What do you mean by line graph?
No, it's like, I forgot the name. It's one using statistics. It's like a big old, the bell curve.
Well, bell curve is a little different. That's a distribution, which we're not ready for yet. We'll get there in a few chapters. What I'm looking for, I'm sorry, what?
The graphs with the boxes where they show the outliers.
Box plot.
Yeah.
So we have a box plot, we have a dot plot, we have a stem plot. Does anyone know what a stem plot is? Have you guys seen them before? We have a histogram. Yes, no, maybe so. So these are all methods of displaying quantitative data. Let's take a look at some of them in action. So different graphs below display the saturated fat content in 69 fast food hamburgers. The data were collected in January 2017 from online nutritional information provided by the fast food restaurant chains. So this is my dot plot. Why is it called a dot plot? Well, it's got lots of dots. That's why it's called a dot plot. Where do we put the dots? Why are there, for example, 4 dots at 15? What do those dots physically represent?
Those be the different fast food hamburgers?
They would be which specific ones? There's 69 of them. So which ones are those dots representing?
The ones that have 15 grams of saturated fat?
They're the ones who have 15 grams of saturated fat. There's 4 of the 69 that have 15 grams of saturated fat. Now, I personally want to try that 29. That looks good, but I don't know what it is. Meanwhile, I'll just keep going. Ooh, the Supersonic Burger. Never had one, but I might have to now. The Supersonic Burger has the most saturated fat. How many grams? Ooh, how many grams does it have?
35.
35. I missed this dot. It was being covered by something. So 35 grams of saturated fat. Yummy. A McDonald's hamburger has the least. How much does that one have?
One.
It's got to be one. Well,
2.
Well,
actually, let's take a look. 10, 9, 8, 7, 6, 5, 4. I think 2.5. I think they go by 0.5s. I think they go by, because if you go to 10 and then 9 and then 8, and then after the 8, there's like one really close, and then 7, and then 6, and then 5, and then 4, and then 3, and I think 2.5. So then McDonald's has 2.5 grams. Agreed? Is that we all reading it the same way?
Yes.
Now, an In-N-Out Burger has 5 grams of saturated fats. Circle A dots that might represent this burger. A dots. Which are the dots that might represent In-N-Out? Which dots might represent In-N-Out if it has 5 grams of saturated fat?
The one that's above the 5.
Yes, one of these that are above the 5. There's 5 of them. Any one of those 5 might be an In-N-Out burger. What percentage of the burgers would keep a person under the government's recommendation of less than 20 grams of saturated fat per day if they also ordered small fries, which have about 5 grams of saturated fat, and ate no more saturated fat that day? So this is all we had. What percentage of burgers would fall under the recommendation of 20 grams per day?
Whatever is 15 or below.
Whatever's 15 or below. How many are there that are 15 below? I just quickly counted them. What do you guys get?
$44, I think.
44, that's what I get. So is your answer 44?
No, because it's not out of 100.
So what should the answer be? Anyone, what should your answer
If
be?
you scroll up on the page, we could see the total. I think it was 69, right? So 44 out of 69.
Okay, yeah, I didn't remember that. I was actually counting them. 1, 2, 3, 4, 7, 8, 9, 10, 16, 1, 2, 3, 4, 5. Yeah. Okay, but I count 68 actually. Is that 1, 2, 3, 4, 5, 6, 7, instead of 12, 13, 14, 13, 21, 22, 20, 25, no, 69. So the answer will be 44 over 69, whatever number that is. The percentage is how many out of how many, right? 44 over 69. Do we agree?
Yes.
Which is like something like 2/3 approximately. Roughly 2/3. Okay. All right, a ruler drop experiment. A 5th grade class of 27 students conducted a ruler drop experiment. One student made this dot plot using X's, not dots, of the student's reaction times in centimeters. What appears to be the student's procedure? How do we measure reaction times? What are the students doing to measure reaction times?
How quickly they can grab it. So the closer it is to 0 centimeters, or I guess 1 centimeter, that's the faster they grabbed it.
Yeah, exactly. The faster their reaction time is, the quicker they grab it, the closer to the top they'll grab it. So we can measure reaction time by how far away from the top they grabbed it. And this student made this little dot plot using X's of the centimeters below the top and how often each of them occurred. Is this a good dot plot?
No, the numbers aren't in order.
The numbers are not in order. So let's construct an appropriate dot plot. Which number should go first?
1.
1. What number should go last?
29.
And which numbers go in between? Answer: all of them. You don't only do what the student did, which is write the numbers that actually occurred. You don't skip spots. So 1 occurred once. What about 2? How many times did that occur?
0.
How about 3? Oh, by the way, 1 occurred twice, not once. How about 3?
0.
2? What do you see 3? I don't see 3. Do I see 3?
No, 0. No, it didn't happen
How about 4?
twice.
And so on. So key number 1, whether it occurred or not, don't skip a spot. They should all be there. Very important. And I'm not going to finish it because I'm tired, but you all agree on how to finish it? Is there any question on how it's done? Yes, no, Phil, seems reasonable. I hope. Okay, that's a dot plot. Very important method. Dot plots, very important. Okay, next, histograms. If you have lots and lots and lots and lots of data points, making enough dots is going to be an arduous and long process. So instead of making a dot plot, we make what's called a histogram. And for a histogram, we actually don't list the individual data points like we do with a dot plot, but we lump them together. For example, this bar, this class, this grouping has how many burgers in it? how many burgers fell between whatever this number is and whatever this number is?
8.
8. That's the frequency. It occurred 8 times. Now, what is the lower end of the box and of the class, and what is the upper member of the class? From where to where do we have this little 8 burgers? Where do we start and where do we stop?
I'm gonna guess that's 5, right?
Well, we stop at 5.
Mm-hmm.
And where do we start?
That's 2.5 maybe.
2.5. It looks like each bar is with 2.5 grams. So 2.5, 5, 7.5, 10, and so on. By the way, if I landed exactly 2.5 on the dot, do I put it in the left or do I put it in the right?
Left.
Okay, why the left?
Because the right is for 5.
Well, the right of 2.5 is anything that falls between 2.5 and 5 goes in here. So 2.6 would go in here, 2.9, 3.2, 4.7. But the next one is between 5 and 7.5, correct? So if I landed exactly 5, does it fit in the left one or does it go in the right one? How do I know what a borderline number goes into? Because it's in the border of 2 groups, 2 classes. So does it go on the left or does it go on the right? Which one do I do? Anyone? Anyone?
Can you give it its own bar?
Just the number 5 should get its own bar. All the other bars are with 2.5 and you want just the number 5 to have its own? Then every borderline case should have its own, or what do you want to do there?
Well, I mean, I feel like it goes in the left because that's 0 through 2.5 and then 2.6 through 5.
Wait. It doesn't say 2.6 to 5. It says 2.5 to 5. So I'm going to give you a hint. Reading is fundamental. That's my hint. Reading is fundamental. Can anyone tell me what my hint is suggesting about this problem?
It says borderline cases going to the bar on the right.
Yeah. Borderline cases go to the right. Now, just so you know, that's not like a universal rule from up on high. It's not like God said, borderline cases go to the right. That's just a choice we make. If you want to go on the left in your own out there in the world research, that's your call. But in this class, borderline cases go to the right. Merely because we choose it to be that way. So, how many burgers had less than 5 grams of fat?
Eight.
8. How many had 30 or more?
Like 1.5.
You can't have 1.5 burgers, can you?
No, so maybe you could say just 1.
Just 1, because if you look at here, the bar is 2. So this is 1. Right? It's a height of 1. Agreed?
Yep.
Yeah. All right. A different version of the histogram appears below. How's it different?
The frequency.
Well, the frequencies are different only because something else is different.
Like how it's spaced out.
So what do you mean by that? Be more specific.
This one's spaced out by 5s.
Yes, the widths are 5s here. In other words, we're grouping more of them together at one point, at one time. So here, each class interval, each width is 5. Here, each width was 2.5, which is better. Which is better. Which
Well,
is
the first one's more, I guess, accurate, you could say.
okay. I like that. The first one's a little more accurate. We kind of narrow them down a little bit more in the first one than the second one. There are reasons why a statistician might prefer this. Maybe you get a better, better grasp of the trends. Oh, as the grams go up, the frequency goes down. Whereas for this one, it kind of keeps bouncing down, up, down, up, down, up, down, So different statisticians might decide on different ways because they're looking at the data and their goal is to have the data support whatever their stance is. And sometimes representing the data one way might be more likely to represent their stance than another. So just be aware of that out there in the world. Okay, and we're gonna stop here. I have a little bit of a headache, guys. So we'll just end a few minutes early if that's okay. So are there any questions on what we did today? Anyone? Dealer? No thanks.
No, but we have a quiz this weekend and the midterm next weekend.
Yeah.
Okay.
The midterm is gonna be how you put up the quizzes as well, like
Yeah. I'm
it's
gonna
gonna be during class.
no, it'll be over the weekends.
Okay, perfect. Thank you.
That way we can do more math in class.
Okay, sounds good. Get some rest and have a great weekend. Feel better.
I make no promises, but I'll do what I can. All right, everyone.